equivalent resistance. Okay, so let us start with a simple circuit. Okay, so this is just I'm going with all the resistors with a combination of series and parallel connections. Or else we add some more. Okay, so this is the resistor. So let it be 1 ohm, 2, 3 ohms, 4 ohm resistor, and again 2 ohms, 3 ohms, 4 ohms, and again so 2, 3, and right. So this is the circuit. So the thing is that we want to find out the sorry. So we want to find out the equivalent resistance. So R equivalent. Okay. So first of all, we must know we need to start from this axis. I mean from this direction. Okay. So this is the equivalent point. I mean here we need to find out the equivalent resistance. Okay. So we need to look from this end. I mean we need to start resolving the circuit from this end. Okay. So let us start with these two elements. Okay. So how about these two elements? I mean the 2 ohm resistor and the 3 ohm resistor. So these two are connected in series. How can we say that these two are connected in series there? So because if suppose this is the current entering to this 2 ohm resistor and directly it is leaving and it is entering to the 3 ohm resistor. There is no any diversion or there is no any sort of connection here. So that is why the output current of this 2 ohm is the input of this 3 ohm. So hence these two are connected in series. Okay. So if two resistors are connected in series, so if two resistors are connected in series, what is the equivalent resistance? We have to add those resistance, that is the 2 ohm resistor and the 3 ohm resistor. We need to add there. So then it becomes 5. So just I draw it as a dotted lines. So these two we need to add. Okay. So then how the circuit can be redrawn? So again, so as it is we need to redraw the circuit. Okay. So this is 1, 2, 3. Sorry, here there is a small mistake here. So just I erase this. Okay. Okay. So this is 1, 2, 3, and again 2 ohm resistor. This is 3 ohms, and this is 4 ohms. Okay. So once these two resistors are being added, so what is the equivalent? So R1 plus R2. I mean these two resistors should be added. So then it becomes 5 ohms. So the resultant is 5 ohms here. So then how we can add those resistance? So it is connected between these two nodes. See, so this is the node. I hope you can follow this. So between these two nodes, we have found out the equivalent resistance between these two points. Okay, let us we call it as between X and Y. Okay, here. So then how we can draw the resistance between this X and Y? So it becomes 5 ohms. So this is 5 ohms. Again, so here we need to find out the equivalent resistance. Okay, so this is the resultant. Okay, then after this, how about the combination of these two resistance? So suppose if we consider this is the input there, so the current is going to divert at these 2 points. Okay, so I mean, so if suppose there is an incoming current at this particular node, so the same current is going to divert at these two 3 ohm resistor and 5 ohm resistor respectively. Okay, so then how we are going to make the, I mean, how we are going to find out the equivalent resistance of these two when two resistors are connected in parallel? So what is the equivalent? So R1 R2 by R1 plus R2. So this is the formula for when resistors are connected in parallel. I mean when two resistors are connected in parallel. So then what is the value here? So just 3 into 5 by 3 plus 5. So 15 by 8. Okay, so let me draw this circuit here, and of course I'll just give the value here. Okay, so just incorporate this value. First of all, we need to redraw the circuit, how it is going to convert again. So this circuit again can be drawn as, okay, so this is point X, already we have quoted there. So this is Y. So if these two resistors are connected in parallel, so this is the resultant. So and what is the value? That is 15 by 8. So 1.87. The resultant is 1.87 ohms. So that we can include here. So it is the resultant. That is 1.87 ohms. And as it is, we can draw the remaining values. This is 2 ohms. This is 4 ohms. Okay. So here we need to find out the equivalent. Okay. Next. So again, I just highlight here. Okay. So now what about these three elements? So that is, let us consider, so this is point A and this is point B. So between points A and B, how about these elements, a connection here? 2 ohm resistor, 1.87 ohm resistor and 4 ohm resistor. All these three are connected in series, right? So see, if you observe the current direction here, suppose if there is a current flow, then it is going to enter the 2 ohm and it is going to leave the 2 ohm. Then the same current is going to flow through the 1.87 and again it is flowing through the 4. So hence the current remains same in these three elements. So hence these elements are connected in series. If three resistors are connected in series, let it be R1 plus R2 plus R3. So then we need to add the resistance value. So that means 2 ohms plus 1.87 ohms plus 4. Okay, so it is 6 7.87, right? Okay, so this is the resultant. Okay, so before that we need to highlight that, so this is the resultant. Okay, so the value is 7.87 ohms. Okay, then again how we can draw the circuit? So again how I can draw the circuit is, this is 1 ohms, This is 2 ohm resistor, this is a 3 ohm resistor, and this is the point A, right? This is B. And between this A and B, we have found out the equivalent resistance is 7.87 ohms. Okay. So then just draw the resistor and include the value. So this is 7.87 ohms. Okay. So here we need to find out equivalent. Then again, how we can solve the further? Suppose I'll go with the other. See, again between this terminal A and B, or between the points of A and B, this 2 ohm resistor and 7.87 ohm resistor is connected in parallel. So then what is the formula when two resistors are connected in parallel? So R1 R2 by R1 plus R2. So then what is the resultant here? Then we can write as 2 into 7.87 by 2 plus 7.87. So let us see what is the value. So just I am using a calculator here. 2 into 7.87 is 15.74, and so that is 9.87. So this is 9.87, and the resultant is 1.59. So 1.59 ohms. Okay. So this is the value of these two parallel connected resistors. So further I can reduce the circuit as 1 ohm resistor, and this is the 3 ohm resistor, and between terminals A and B. So what is the equivalent resistance? So the resultant is 1.59. It is 1.59 ohms. Okay. So this is obtained from this here. Okay. So finally, how about these three elements? Once we found out this value, so these three are again connected in series. So then what is the final equivalent resistance? So the equivalent resistance is, since three elements are connected in series, we can add those values. 3 plus 1 4, 4 plus 1.59. So it is 5.59 ohms. So this is the equivalent resistance. So this is how we are going to find out the equivalent resistance, and I'll let you know where it has been helpful to us. So what is the importance of this finding the equivalent resistance? So the thing is that we need to identify which elements are connected in series and which elements are connected in parallel. So once we know the their exact connections, I mean whether it is connected in series or parallel, then we keep on step by step, we can resolve the circuit and we can find out the values, the resultant value. So this is the one example. Let me take the another one. Okay, so it is okay. So I'll erase this. Okay, so we'll go with the another problem. Okay, so this is the circuit. So solve this circuit and find. So let us see what we can find from this with this method. Okay, I hope you two can parallelly work along with me. So I hope it will be more effective. Okay. right? So this is a 10 volt voltage source. It may be 2 ohms, 3 ohms, 4 ohms, and 5 ohm resistor. Okay, so the thing is that I want to find out, yes, I need to find power drawn by the circuit. Power drawn by the circuit. Okay, so what is the power drawn by this total circuit? So you can use this equivalent resistance finding, and you can find out the value. So just if you want to apply if you want to apply the equivalent resistance technique, you can apply that, or else directly I can go there. Just I will know. See, so here directly I'm coming to this concept. Okay, so these two resistors are connected in series. So what is the equivalent resistance here? It is 9 ohms, right? So let us see and redraw the circuit. I'll be a little bit faster so that we can cover some other examples as well. Okay, sorry. Okay, so this is 2 ohms, this is 10 volts, this is 3 ohms. So then the resultant is 9 ohms. And again, these two resistors are connected in parallel. So then what is the equivalent? So 9 into 3 by 9 plus 3, 27 by 12. Okay, so let's see what is the value. 27 by 12, 2.25 ohms. Okay, so then we can redraw the circuit as 2 ohms, and this is 10 volts, this is 2 ohms, and this is 2.25. And again these two resistors are connected in, okay, these two resistors are connected in series. So then what about the final circuit here? So it is 10 volts and it is 4.25. Okay, so what they have asked, so power drawn by the circuit. So for a resistor, what is the power drawn? So P equal to I square R. Okay, so then we don't know I value, right? Or else we can go for V square by R, or you can use the formula V square by R. So that we will use right now. Okay, so what is the 10? So the supply voltage is 10 whole square by the resistance is 4.25. Okay, so 100 divided by 4.25. Okay, so it is 23.52 watts. Units are mandatory. So this is the power. Which power again? It is the real power. So since the circuit is pure resistive. Okay, so this is how it will be helpful for us, since it is a two loop circuit. So since only the two loops are there, this is loop 1 and loop 2, it is so convenient for us. Suppose if there are multiple loops, like 18 number of loops are there, that is a very time consuming, right? So that is why we go for simulation, that is a different case. But if you want to analyze theoretically, so this is one of the solution. Okay, or else we can apply different theorems. Okay, so this is a simple examples. Next we'll move to the KVL example. Okay, so KVL related problems. Okay, up by using KVL, so we need to solve the circuit. So let us consider a voltage source with two resistors in loop 1 and two resistors in loop 2. Okay, so let it be 1 ohms, 2 ohms, 3 ohms and 4 ohms. The question is that, so find power drawn by the 4 ohm resistor. Let us consider 4 ohm resistor. What is the power drawn by the 4 ohm resistor? So I use KVL, apply KVL. Okay, so we should not go for finding the equivalent resistance here. So we should not simplify the circuit. So as it is, we need to resolve the things. So before that, what we need to do here? Okay, so as it is, we need to redraw the circuit. Okay, so just consider it as loop 1, and this is the direction of current, and this is loop 2, and this is the direction of current. And again you need to draw the polarities. So it is plus and minus. If it is plus and minus, it is plus and minus, it is plus and minus. Okay, and again uh, this is what the issue what we have seen in the last class. So one thing I would like to highlight here is, so all the passive elements, so passive elements in the sense resistor, inductor and capacitor comes under the passive elements. And coming for these active elements, voltage source and current source comes under the active elements. So these are the energy generators. I mean the voltage source and current source. Okay, or any other battery source, whatever it may be. Okay. Next, coming for this passive elements. So these are the energy absorbers. Okay. So resistor, inductor, and capacitor comes under these energy absorbers. So definitely there will not be any potential rise. Obviously there will be potential drop. So that is why we should not go for reversing of polarity. So that is what the mistake we have observed in the previous session. Okay. So now another important factor we need to remember is, suppose an element which is connected between these two loops. Okay, so this 2 ohm resistor is connected between, it is connected between loop 1 where the current I1 is flowing, and coming for this uh, 2 ohm resistor, it is also connected to loop 2 where the current flowing is I2. Okay, so then what we have to do? So suppose if you are applying KVL in loop 1, so this will be the direction of current, so the polarities remain. And if you keep applying KVL at loop 2, so that is, I'll write here, this is loop 1 and this is loop 2. Okay, so then you should write the polarities like this. So then it will be so easy for you to apply the KVL. Okay, so let us start our problem. Okay, so the solution is apply KVL at loop 1. Okay, by applying KVL at loop 1. So then what is the statement here? Algebraic sum of all branch voltages around a closed path in a circuit is always 0 at any instant of time. I repeat once again, algebraic sum of all branch voltages is equal to 0. So here if we consider at loop 1, so apply KVL at loop 1. Okay, so then the first source is 10 volts. Since it is from minus to plus, obviously the polarity is plus. Next, coming for this resistor, so what is the polarity here? It is a potential drop. So then minus, what is the voltage across the resistor? I into R. So we don't know the current value, so then obviously it will be I1. So we have given the term as I1. So since we don't know the value, and of course we need to find that. Okay, I1 into R. So what is the value of R there? 1 ohm resistor. So it is 1 ohm. Next, coming for this 2 ohm resistor, it is connected between the two loops. So then what about the polarity? So it will be minus. So then, and see, it is I into R, right? I in the sense, since it is linking the two loops, then we have to write it as I1 minus I2 into 2 ohms. Okay, so is equal to 0 as per KVL. So then 10 minus I1 minus I1, sorry, minus 2 into I1 plus 2 into I2 is equal to 0. So then how it becomes? Minus 3 into I1 plus 2 into I2 is equal to minus 10, or else we do one thing. Okay, so let it be equation, let me cross check, minus 3 into I1 plus 2 into I2 is equal to minus 10. Okay, so let it be equation 1. Okay, next apply KVL at loop 2. Apply KVL at loop 2. Okay, so if we need to consider this circuit. Okay, so let us start with the 2 ohm resistor. Okay, so this is the direction of current, so it is going from plus to minus, so the polarity will be minus. So what is the voltage across the resistor? I into R. Again, what is the current flowing through this 2 ohm resistor? Since it is linking the two loops, we can take the I2 as reference. I2 minus I1 into R. R value is 2 ohms. Okay, next after that, so it is going through the 3 ohm resistor, so we need to consider 3 ohms. Again the polarity is minus 3 into I2. Next it is minus 4 into I2 is equal to 0. I mean it is I into R, it is I into R is equal to 0. So if we simplify the circuit here, so minus 2 into I2 plus 2 into I1 minus 3 into I2 minus 4 into I2 is equal to 0. So how many I2s are there? It is I2, I2 and I2. So 4, 3, 7, 7 plus 2, 9. So 2 I1 minus 9 I2 is equal to 0. Okay, so let it be equation 2. So I hope we can solve this with finding two unknowns. Okay, solve by solving 1 and 2. So just I will let you know in tutorial class that how we can solve the unknowns in the calculator. Okay, so but as of now I'll go with the old method. So how we can solve these two? Minus 3 into I1. So just minus 3 I1 plus 2 I2 is equal to minus 10. So this is an old technique. Right now directly by using calculator we can solve the unknowns. Even for 3 by 3 matrix also is equal to 0. So then how we can do this? I can go for multiplying with 2 and multiplying with 3. All right. So then how it becomes? Minus 6 into I1 plus 4 into I2 is equal to minus 20, and it is 6 into I1 minus 9 is 27 into I2 is equal to 0. So how it becomes? It becomes uh, no. Okay, right. So same polarities we can use, right? I think it will become opposite, I think so. Okay then. So directly can we use, I think. So minus uh, it will be 23 into I2 minus 20. So I2 equal to, so 20 by 23. Let me check. It is I2 equal to 0.869 or 87 approximately. So I2 maybe this is okay. So we got I2. So the same we can apply for this value, we can apply for any of these equations. Okay, so let me substitute in equation 1. Okay, so let it be equation 3. So 3 in 1. So then what it becomes? Minus 3 into I1 plus 0.86 into 2, that is 1.72 into I2 equal to minus 10. Sorry, after substitution only it is 1.72. Okay, so minus 3 I1 equal to minus 10 minus 1.72. So all the minus get cancelled. 3I1 equal to, so 11.72, right? Okay, so I1 equal to 11.72 by 3. So it becomes, okay, it becomes 3.9 amps. So I1 is, so I'll write it here. So I1 equal to 3.9 amps and I2 is 0.86 amps. Okay, so what they have asked, so find the power drawn by the 4 ohm resistor. Okay, so we know that what is the power uh, drawn by the resistor, it is I square R. So I, in the sense, this is the current flowing through the 4 ohm resistor, that is I2 is only flowing through the 4 ohm resistor. Then we can substitute the value of I2 here. So I2 in the sense 0.86 whole square into, what is the R value, 4. So let me check. 0.86 into, it is 2.95. It is 2.95 watts. So this is the power, real power drawn by the 4 ohm resistor. Okay, so by applying KVL. So this is the method. So I'll just give you a sample problem. So I want to know the answer from you. So let me see how this subject is reaching to you. I mean, how this concept is reaching to you. Just I'll give you a simple circuit. So I want to see your answers in the chat box. Okay, let me see what is your response. Or you can go for any other simple technique. I want the solution, and let me see if you are able to write. Uh, I think you cannot show the screen, right? No issue. Just I'll give the simple circuit. So this is a 10 volt resistor, 10 volts voltage source. Let it be 1 ohms, 2 ohms. Let it be 2 ohms. Okay, this is 2 ohms, 3 ohms. Again, it will be 4 ohms. Okay, so this is the circuit using KVL. Using KVL, what is the power drawn by 4 ohm resistor? What is the power drawn by the 4 ohm resistor? So I want to see answer from you.